During this session, I'm going to be introducing some nuclear reactions which are wholly artificial. They're described or named artificial or induced transmutations. That means change which has been brought about by an outside influence of some sort. And to try and explain these, I'm going to construct a nuclear reaction equation and just show how that we can follow exactly what's happening. So first of all, let me introduce you to an instrument. A cloud chamber. Now, a cloud chamber is a device which allows us to see the paths of an ionizing particle. So it's completely reliant on actually the impact of ionization. So you wouldn't really see any gamma radiation here. But what happens is that the cool chamber is cooled and then supersaturated with alcohol. So we've got this area which has cold, very, very saturated alcohol. And this situation means that if there's any ionoforms, immediately condensation is created. So that means that if this condensation is created, we can actually see a trail of where the particles have travelled. So this is kind of a starting point, a useful starting point. So if you have a radioactive source, what we'll see is we'll see the different trails of the different radiation being emitted. Now, why is this useful? Well, it's useful for seeing and identifying different types of radiation, and as we know that we should be able to see how the different radiation travels different directions depending on magnetic fields. It also gives us some idea of exactly what's going into and out of reactions. Example here. So Rutherford experimented with artificial transmutation by firing alpha particles at nitrogen gas. Okay. And what he did is, by doing this simple experiment, he was able to look at some of the trails which were created in the cloud chamber, and from that identify exactly what was going on. In this case, he managed to identify that by firing alpha particles, so this comes across as the helium nucleus, at the nitrogen, he was able to create oxygen and hydrogen. Okay. So this is an artificial transmutation. What we've got here is that if you look carefully, you follow the different trails, you would see that there's some situations when a particle is travelling, it will collide, and then from that collision we'll have a recoiling nucleus and a proton. So we can see that three directions of particles from this picture here, which shows a cloud chamber. Now, I've put the idea of alchemy here. So it's the idea of creating new elements. Okay. Let me give you an example. Okay. So my example here is, you're given a situation. A sample of oxygen-16 is bombarded with neutrons. If one of the resulting products is deuterium, what is the resulting nucleus? So here we've got to think about what we know and what information we can put together. We've been told very clearly that we've got oxygen-16, which means that it has atomic mass of 16 and atomic number of 8, it being oxygen, is bombarded by neutrons. So a neutron is shown here with an atomic mass of 1, but no protons, so atomic number of 0. This is collided into, they collide together and they create a deuterium, and all that is a hydrogen nucleus which happens to have 1 proton and 1 neutron in the nucleus, and then a mysterious product which we've got to try and work out. So how do we work this out? Certain things kept the same. The mass and atomic numbers must be the same on both sides of the equation. Okay? We haven't changed the number of protons. We haven't changed the number of nucleons. So if the total atomic mass on one side is 17 in total, that means the total atomic mass on the other side must be 17 in total. The same thing with the number of protons. With that knowledge, I can work out that the only resulting nucleus which could fit into here will have a proton number of 7 and an atomic mass of 15. So I recognize it's nitrogen. So there's an example of artificial transmutation, and this is the introduction, or the first thinking about nuclear reactions, and how by just thinking about that we can't create any new matter, we can't create any new charge, it allows us to work out exactly what new materials might have been produced.